Welcome to this session on project quality monitoring. This is a subunit of the bigger unit which is on IT project progress and control. So we have looked at other aspects that need to be monitored as part of IT project progress, control and monitoring, but we want to now focus on monitoring project quality. So we'll start with a brief recap. In the previous session, we looked at monitoring effort, where we are looking at monitoring the human resource that is part of the project, and the key way in which we do this is through the use of timesheet, where we calculate allowances or project allowances either on an hourly basis or per day, according to the schedules that have been prepared as part of project planning. Then we also indicated that when it comes to the use of timesheets, especially in an instance where they have previously never been used before, it's important that as a project manager, you introduce them in a systematic way and with a lot of awareness to ensure that they serve the purpose to which they are intended, which is simply tracking the amount of time spent on project activities. We also looked at the aspect of monitoring costs, where we talked about the aspect of cost versus price, where the cost is simply the amount that is spent to procure project equipment, while the price is the amount that is paid for leasing out, ideally within the organization, of that same equipment when it's not being utilized within the project. We also looked at monitoring project specific training costs, where a particular training is initiated as a result of that particular project, and that is a cost on the project itself. We also looked at aspects of accommodation and lodging, especially where we have employees working off-site, sometimes even international activities that are part of the project. We talked about show expenses, which we collectively called travel expenses. We talked about consumables, as well as issues of insurance, which we said most times are borne by the institution or the organization in which the project members are permanently based. So now that we have looked at these critical aspects, we want to now focus on quality monitoring, which is a vital element in ensuring project success. Now, quality monitoring is essential, ladies and gentlemen, because it allows us to maintain a high standard throughout the project lifecycle. It focuses on a number of key activities or objectives, number one of which, of course, not the most major, but we'll just talk about them as part of the introduction. Quality monitoring ensures that there is consistency, because as we continuously monitor the quality of deliverables, we ensure that outputs remain consistent with the project's requirements and what the client expects. It also ensures that we detect defects early in the life cycle of the project, as opposed to identifying and dealing with defects once the system goes live or the project is implemented. Quality monitoring also helps us to meet stakeholder expectations. It also prevents a very important aspect of avoiding costly reworking of deliverables and products. It also ensures that we adhere to standards and are compliant to industry regulations, as well as contractual agreements, which are very important, especially for projects in highly regulated industries. So that is what we are going to look at in this particular session. When it comes to the actual monitoring of quality, there are two major phases. We have the checking aspect as well as the review. Now, here we are saying that the work which is being produced, or the products or deliverables that are being produced in the project, need to be checked or reviewed as it is in progress. And we also need to ensure that we test the final or finished product. When we look at the review process first, it is important to apply checks at sensible points in the project lifecycle. We need to agree, as we will discuss in the next few slides. Generally, it is not always feasible to apply checks at each and every aspect of the project. For example, if you're on the construction stage and then you are applying checks per module, imagine you have 1,000 plus modules. It's going to greatly affect the completion of the project and other key aspects. So now, it is not every stage that requires a check. So as we normally do, we're going to discuss different points at which you can apply quality control checks. And then it's up to the context, it's up to the project manager to indicate or to select which check they are going to apply on a particular project. Now, while it is not good to check at every point, in the other extreme, it is not it will not benefit anyone by waiting until the whole project is produced and then we perform checks. Usually, you will find that there is something that is actually you find sometimes even the whole system will fail to work because we did not pick the small errors when we should have done so. So the idea here again is to balance. Now, we have what we call monitoring checkpoints. We have mentioned the fact that, of course, we cannot say for every project do ABCD or check at this point. We'll just look at general points that at which we can actually apply these checks. So, number one, you can apply checks for key project milestones according to what is in the project plan. So if in the project plan you identified certain key deliverables that are key to the successful completion of the project, then you can say for each of these milestones, we are going to perform a check. Or you can apply checks when you are moving from one key stage to the other. So if, for example, you have completed your analysis activity, you can perform your quality check before you move on to the design phase of the project. That's another way. You can also now here, if you are using new standards in a project which have not been done before. Now, if that is the case, because you are doing something for the first time, then of course it's important that you apply checks to ensure that you are conforming to what the standard is stipulating. This also applies to technologies that are new to the team as well as new methods that have previously not been utilized in the team. Then for those activities where you are doing it for the first time, of course, the number of checks you perform will be different to those activities that you have done before you have the experience as a project team. Additionally, you also ensure that there are checks when you have staff that are not so experienced or staff who have come into the project team. You are using standards that you have used before, but for them, that is the first time that they're using those standards. So, for such deliverables produced by such team members, either inexperienced, meaning maybe they are straight from school, they don't have industry experience, or inexperienced with a particular standard, particular technology, then in those instances you ensure that there's additional checks or you put in place checks to actually review what is being produced, again for the reasons that we talked about of conformance, detection of errors, and so on and so forth. Testing, ladies and gentlemen, is also a quality check. And here, as you are looking at the finished product, there's a hierarchy of tests that you can apply. So you can, number one, test individual components. You can test programs, you can test modules. You can also perform integration testing when you're linking programs, modules, and so on to see how they're able to relate to each other. Then you can also do a complete system check to see how the various components which you've also tested are able to work as a cohesive whole. And also check for requirements adherence. That is important as you are doing the system check. Then the customers again can perform user acceptance testing. This is why now they use the finished product to sign off on whether or not it meets their requirements. And only after that is done do you go ahead to install it in the user environment. So that is, user acceptance testing is a contractual activity where the user legally signs to say this system that has been produced is in adherence to the requirements, is what we wanted, and then they are able to now fully utilize it after you install it. So now you may have additions to the test for finished products. For example, if you have a system that's going to be used for the sensors, for example, you may perform load testing just to check how it stands up to multiple millions of transactions in a given period. So again, the type of system or the type of project can determine what types of tests will have more prominence compared to others. All right. Now, what are the techniques, ladies and gentlemen, that we can employ in a project to ensure that the product or deliverable is adhering to what it's supposed to? Number one, we have what we call self-checking. Self-checking is one of the techniques that is applied highly in total quality management, and this particular technique relies on the author of the work having a good understanding of the requirements and also the skills and techniques needed to identify any errors that may be in the product that they have developed. So, in short, you develop something. If I write a particular code or I complete a particular work package, then as part of my completion, I go through to check for errors and also requirement adherence. So now, one of the weaknesses of this is that if the person who is conducting the self check is not skilled or they have not understood the requirements, then it's very possible that they overlook very key or prominent errors in that particular product. So it is only as good as the person who's conducting the self check. That is one of the major disadvantages. Additionally, if the person or the author has misunderstood the requirements, that misunderstanding will carry forward into the actual product and it will not be picked because what is reflecting in the product is according to how they have understood the requirements. That is why when it comes to self checking, it should not be used in isolation. And actually, this one is true for all the quality review techniques, in that we need to have at least two or three so that we have one indicating or confirming what the other one has found. And other times, to cover the weaknesses of the other technique, another one can be used. So that is why, but with self-checking, it is actually encouraged that you should have other means of verifying quality adherence of that particular product. The second one is what we call the team leader review. Now, this is a technique that requires the team leader to go through the products that are produced by the subordinates. Depending on the size of the project team, this can be the project manager, or it can actually be a team leader who is in charge. Let's say we have a lead programmer, then they are reviewing the work of other programmers, lead analyst, risk manager, and so on and so forth. Now, the idea here is that when you find errors as a team leader in a piece of work, you give it back to the author so that they're able to work on those errors. Once they are done, then again you review with the same purpose of checking the quality of the product. Then it is a very good opportunity for coaching, especially where you have staff who are new, who are not as experienced. So you are not there just to detect errors, you are helping them to fine tune their technique, more efficient ways of working. It's a mentoring actually activity where you are able to build the capacity of those that are not so skilled as the team leader. That is one of the advantages of this particular technique. And just like is the case with the self-checking, it is only as effective as the skills of the team leader or the reviewer again in this case. And we will have instances, and it is actually prominent, that when you have a multi-skilled team, meaning you have different parts of the project requiring different skills, it's possible that the team leader may not actually have the skills that are required to review a particular subordinate's work. So now, if that is the case, you will find that the review may just become an academic exercise because the team leader has no capacity to actually give meaningful input to what has been done. Then in that instance, team leader review becomes a bit ineffective. And then additionally, if you have a lot of subordinates per team leader, it may build a bottleneck in the sense that you have a lot of modules to review and those programmers will not proceed to the next until you have approved. So all of them will just be seated waiting for the team leader to review. The more the people to review, the longer the process will take. We also have, ladies and gentlemen, peer reviews. Peer reviews, these are similar to team leader reviews. The only difference is that it is people of the same rank, IT specialists of the same rank, and then one gives the work to the other one to review. Now, this can be used and is mostly used to help or to work with the team leader review, especially in that instance we talked about where you find the team leader may not necessarily have the skills to review a piece of work. So in that case, a team leader may delegate to a subordinate to review another subordinate's work. So as that is being done, again, of course, it depends on the skill of the reviewer, but it is important that the objective of the activity is highlighted from the onset. Because given the fact that the subordinates are equal, they are peers, there is a very high possibility of rivalry deterring from the activity itself. In that you find that instead of someone taking the review or the criticism or the critique in the manner in which it is intended, they may take it personally. Or instead of detaching from the work, others will think they are being criticized by their colleague. So it is very important that for this particular technique to be effective, the team leader must specify the objective, including how the critique should be taken and what form the critique should take. Because sometimes subordinates, because of the nature of their relationship with a colleague, they may end up going into other non-relevant issues and make those part of the critique. So the objective must be clear. Both members must know what is the essence of the review and what is expected and what is not expected. That is a peer review. Then we move on, ladies and gentlemen, to the walkthrough. So a walkthrough is simply a group of people which is done on a particular product and can be very effective because the skills, knowledge, and eyesight of many people, the ability to spot errors, are brought to bear. Now, as you are running a walkthrough, if it is not managed properly, you find, number one, it may go on for longer than necessary and the objective may not be met. So it relies heavily on good chairmanship to guide the activity, to guide members, to also ensure that they keep on track. And the major objective of a walkthrough is to detect errors. It is not to offer solutions. And the author should be there to take note. Then once those errors have been identified, away from the review, the author will again sit and go through to try now to find solutions to what has been detected. And usually walkthroughs are done within the team itself. So when a particular programmer says I'm through with this particular product or deliverable, or analyst has drafted the requirements, or the designer has designed the interfaces, then they'll say I'm ready, and then They walk people through and they get input from fellow experts. Last but not least, we have, ladies and gentlemen, the Fagan inspection. Now, Fagan inspection generally are known as formalized walkthroughs. Reason is that they have key steps that are done as part of the inspection. We can see the author or the inventor of the Fagan inspection, which was devised for IBM, but now is used in multiple disciplines. So, once a particular author indicates to the project manager that they are through, they are ready for review, then the inspection is triggered. So this inspection has 6 distinct steps. We have number 1, the planning stage. Now this is where a trained and team members for the Fagan inspection are all trained on their roles and what they are expected to do. So in this particular stage of planning, a trained Fagan moderator organizes the inspection and nominates people for the roles of inspector, number 1, the reader, and the scribe. Those are 4 distinct roles with the moderator. We have the moderator, the inspector, the reader, and the scribe, who will take note as the inspection is ongoing. And then they will also, ladies and gentlemen, indicate or document when the date of the inspection will be, how long it will run, and the purpose or the objective of the meeting. That is part of the planning stage. Then when that is done, we go on to the next step. Okay, my machine is misbehaving. Oh, there we are. We'll go into the overview. Now this overview is optional. This is a meeting that can be used to provide background information on the work or the Fagan process, or to assign particular inspection tasks to individuals. Practically, usually you find that TORs are sent to individual members with a quick rundown of their roles and responsibility in the inspection. But if time allows, logistical issues allow, venue, time, and so on, transport allowances, you can actually have a face-to-face meeting where you tell specific members what is the role and so on, and then also give them particular duties that they're going to perform during the inspection. Then we'll move on to the preparation, and this is where the individuals who have been called for the inspection prepare by examining the material and developing their understanding prior to the review. So meaning that the work that is going to be part of the inspection is given to members before the actual inspection, so that they go through, they familiarize themselves with the activity. And then that's when now we go into the meeting, and this is a very structured meeting chaired by the moderator. The reader, who was nominated previously, paraphrases the item, and each inspector, including the author and the moderator, reports defects in the item, and these are recorded by the scribe. Then we move on to rework. This is where now the author takes the list of defects, and after they rework, they correct, they categorize the errors and what they have done by severity and type. Then in the last stage, a reviewer nominated by the moderator checks that the rework is complete and that the defects have been categorized correctly. The result of the inspection is recorded on the database, and the moderator signs off on the inspection. Statistics are the major strong point of a Fagan inspection, as can be seen on the slide. So they help to ensure the cost of the inspection. They also produce defect rates for the project overall. They identify hotspots in a project. In short, it's saying you identify areas that need close monitoring within the project based on what has been identified in the inspection, and then it also gives us an indicator of matrices that we need to estimate the effort required for quality management. Now, one of the major disadvantage of this very thorough instrument for monitoring quality is that it is time consuming and it requires people to be trained for them to perform their roles and be able to get the benefits that are there in the inspection. Then, very importantly, it is expensive. Highly structured, some inspections even require selected venues, allowances for participants, and so on and so forth, which is not cheap. Okay, I think I said last but not least, but this one is the last but not least. We have external review. Now, sometimes it may not always be possible, or you may not get an objective view when you are using the team that is part of the development process to review their products. So, external reviews come in that it is somebody who is external from the project who is invited to check the review or the products that have been produced by the project. Now, this can be quality assurance department or a consultant who can be brought in from outside based on their experience and so on and their record. Then they come and review the work. Major disadvantage of this is that of course it is expensive. If it's a consultant, there are consultancy costs, there's expenses, accommodation and so on. If it's an organization, also the same. But on a large project, you will find that there's always, ideally, or not there, there's always, ideally there should be a provision for quality management, meaning you budget. So if the plan is to have an external review, how much will it cost? If it's a consultant, that should be part of the project budget. So that's why the major disadvantage is that it is expensive. Now, if someone is coming from outside the organization, you give them the materials, they go through, then they come to review. Of course, you give them a period of time for them to get acquainted with the materials before they come to you, but they may not have, maybe they may not, they will not have the same familiarity that you have as a developing team with the requirements, with the standards for that particular organization you're developing that project for. So you may find in instances certain things that should have been brought out or that should be brought out may be overlooked because the external reviewer does not really have that in-depth understanding of the requirements of the project, the context in which it is being developed, and so on and so forth. And as you are conducting your reviews, you don't conduct for the sake of conducting, as has been highlighted by the FACAN inspections. You need to document what you have found, what errors were found, how they were dealt with, who was the author, when was it reviewed, when was it corrected, when was work signed off, is a team leader review, peer review, check, and so on and so forth. So then a number of equipment which we can use to document. So we have these. Okay, so whether you are using one, two, three, whatever number of techniques, it is very important that you use that information to control, to continue monitoring, to assess, to evaluate, just like we talked about at the beginning of this lecture on project progress. And that, ladies and gentlemen, is IT project progress with a focus on quality management and control. Thank you for your attention.